size over here, 6 inch.
So we've been very fortunate because we have funding from the Precast Concrete Institute, their foundation, and so this allows Greg and I to co-teach this course, but also it offsets student material costs so that we can do these sort of large-scale projects that normally would be out of financial range for the students. And so this project in particular, we here at NC State always think it's really important to get people's hands dirty and to get them actually making with the materials. And because we have such a strong shop at the College of Design and we've got this wonderful facility here on Centennial campus, we sort of merge those two things together. So at the shop, the architecture students build the mold and for a precast panel, and then they bring that here to the constructed facilities lab. So right now the students, the architecture students and the engineer students are working together to try to cast a full scale, just not quite full size precast panel.
So in the Precast Concrete Studio that we're co-teaching with Professor Gulling, we have a few engineering students and they're working on teams of architecture students to provide engineering support for the project. So in the case of the panels we're casting now, that would mean designing the concrete mix, calculating the reinforcement requirements, designing the structural loads for lifting and assembling, and rigging the panels and figuring out how the panels will attach to our simulated steel building. So it would be the roles traditionally filled by the structural engineer on a real project. So this is our 4th year teaching this studio. We've been teaching one course per year, every year for 4 years now. And we've had, I think, very good success with it. We've had quite a few students each year, on the order of 16 or 18 students. About 3 to 6 of those students are engineers. The remainder, the bulk of the students are architecture students. And I think it's been very successful for both groups. I think that the architects, of course, have to tailor their designs to some of the practical constraints, and the engineers have to learn to be forgiving and understanding of the architecture. So of course, on a real job, those disciplines have to work together all the time. We don't see that collaboration quite as much as we might like in the university setting. So I think this studio is a good example of an area where we can bring the engineering and the architecture disciplines together, and each can learn something from the other, and we can create some very unique projects with both of those groups of students working together.
Precast panels in general can be used to carry building loads, so the exterior of the building, but they can also be used as a building envelope to make the enclosure for the building, and that can be hung in a non-load bearing way onto a metal frame or a precast frame. So the students for this particular project are going through the process of constructing the panel, and then we're going to be putting it onto a steel testing frame that is on a shake table at the construction facilities lab. And so we'll be testing the hardware and pieces for lateral stability. But the students, to me, the learning experience for this project is to go through the construction and manufacturing of a panel, but then also stripping it from the mold and actually having to erect it onto a frame. So it becomes representational of the manufacturing of the panel, but also the construction process of it.